Evening, everyone. Okay, so once again, back again with our lecture, with our lesson lah for basic thermodynamics class lah. Okay, so in this lecture today, okay, we will be starting a new chapter which is chapter 4 lah. As you can see here on this slide. Okay, so in chapter 4, we will be learning about perfect gas laws lah. Okay, so we'll be studying more into gas lah. Okay, so without further ado, let us start our lesson for today. Okay, so in chapter 4, okay, so we are going to study about perfect gas laws. So in perfect gas laws, this is what you are going to um, this is what we are going to study together lah. Okay, so one of it is the first one. Let me explain. So kinetic molecular theory applied to perfect gas laws. Okay, so we'll be studying the theory lah. Okay, the kinetic molecular theory lah of these gas laws. Next is the measurable properties of the gases. Okay, next is the Boyle's law, Charles law, Avogadro's law. So these three laws we will be studying about the definition and understanding these three laws. Okay, and the ideal gas law, and last but not least is the deviations from ideal behavior. Okay, so all of this will be covered in this slide and in this chapter. Okay, so first things first. Okay, perfect gas laws. Okay, perfect gas laws. So what is perfect gas laws? Okay, so a perfect gas law is also known as the ideal gas law. Okay, so it is a fundamental principle in thermodynamics that describes the behavior of an ideal gas. Okay, so perfect gas law is also known as ideal gas law. Okay, so basically it is a fundamental principle that describes the gas behavior lah. Okay, so okay, first here. Okay, so what are the ideal behaviors here? What are the ideal behaviors of a gas? Okay, so let me read this first part. Okay, so one, particles are points in random motion. Okay, so these are one of the ideal gas behaviors. Okay, so which is particles are points in random motion. So what does this mean? Okay, this means that the gas particles are treated as having to no volume and moving in random direction and in wide range of speed. So basically particles are moving in random motion. Okay. Next, particles do not interact. Okay, so this is one of the behaviors of an ideal gas lah. Okay, they do not interact. So this means there are no attractive or repulsive forces between gas particles. They behave independently of each other. Okay, so basically the gas particles, okay, they behave independently lah. Okay, they do not interact with one another. Alright. Okay, so just now we have studied about the behaviors of ideal gas or perfect gas. Okay, so now we're going to jump into the kinetic molecular theory applied to perfect gas. Okay, so the kinetic molecular theory is a model that explains the behavior of ideal gases based on the motion of their constituent molecules. So the theory assumes the following lah. Okay, so these are one of the kinetic molecular theory lah. Okay, so this is the theory lah. Okay, this is the behavior lah. So first, gas molecules are in constant random motion and move in straight lines. Okay, second, gas molecules have negligible volume compared to the volume of the container they occupy. Okay? Third, gas molecules do not interact with each other except during collision. Okay. Fourth, the average kinetic energy of a gas molecule is proportional to the absolute temperature of the gas. Okay. So this is kinetic molecular theory applied to perfect gas. So all of this you must remember, yeah. Okay. So this is the theory lah. Okay, ideal gas laws. So, applying the kinetic molecular theory to the ideal gas law, we can derive the following relationship. So, first, the pressure of a gas is proportional to the number of molecules present and the average kinetic energy. Okay. As the temperature of the gas increase, molecules move faster and collide with the walls of the container more frequently and increasing the pressure lah. Okay. Second, the volume of a gas is proportional to the number of molecules present and the average kinetic energy. As the temperature of the gas increases, the molecules move faster and occupy more space, increasing the volume. Okay. Third, the temperature of a gas is directly proportional to the average kinetic energy of its molecules. So, this says, as the temperature of the gas increases, the average kinetic energy of the molecules increase, causing the gas to expand. Fourth, the number of molecules in a gas is proportional to the pressure, volume, and temperature of the gas. This relationship is described by the ideal gas law, which is the formula here lah. PV equals to nRT. Okay, where n is the number of moles of gas present. Okay, so this is ideal gas law lah. So this is the relationship between kinetic molecule theory to the ideal gas law lah. Okay. Okay. So we have studied theory, ideal gas law. We have studied kinetic molecule theory applied to gas law and perfect. What is perfect gas law? Okay. So next we are going to jump into the laws lah. Okay. So the first law that we are going to jump into is Boyle's law lah. Okay. Perfect gas laws. Boyle's law is involved in perfect gas laws lah. Okay. So let me explain what is Boyle's law to you. Okay. So Boyle's law, okay, is a fundamental principle in physics that describes the relationship between volume and pressure of a gas at constant temperature. The law states that the pressure, known as P, of a gas is inversely proportional to its volume, known as V, when temperature T is held constant. In mathematical terms, Boyle's law can express in P1 times V1 equals to P2 times V2. So Boyle's law is expressed in this equation lah, in terms of mathematical terms. Okay. So what is P1 and V1? Okay, let me explain. P1 and V1 are the initial pressure and volume. Okay. P represents pressure, V is volume. Okay. Respectively, P2 and V2 are final pressure. P2 is final pressure and volume V2 is the final volume. Okay. Okay. As you can see here. Okay. Example here. As you can see here. This first diagram. As you can see here. For instance, okay. This one, piston ring example lah. Piston ring 5 kilo load lah is pressing against the container. So this is air lah. Okay, this is air. So this is 5 kg load. This one is before. Okay, so this is V1 and P1. So basically before is pressure 1 and volume 1. So after the load acts upon the gas, okay, then it is called P2 and V2, which is final pressure and final volume. Okay, so that is mean by P1 and V1 and P2 and V2. Okay, so we have studied about Boyle's law. What is the relationship of Boyle's law? Okay, so now we are going to jump into the second law, which is Charles' law. Okay, so let's start. So Charles' law is a fundamental principle in the physics that describes the relationship between the volume and temperature of a gas at constant pressure. Okay, the law states that the volume V of a gas is directly proportional to the absolute temperature T when the pressure P is held constant. In mathematical terms, Charles' law can be expressed as, okay, so Charles' law can be expressed in this equation. V1 over T1 equals to V2 over T2. Okay, so basically Charles' law is whenever we talk about Charles' law, it always involves volume and temperature. For Boyle's law, when we talk about Boyle's law, it always involves pressure and volume. Okay, so remember this lah. Okay, so let me explain here. When V1 and T1 are the initial volume and the temperature respectively, and V2 and T2 are the final volume and temperature respectively. Okay, so anything involves volume and temperature is known as Charles' law lah. Okay, so we have learned about Boyle's law and Charles' law. The third law we are going to study is Avogadro's law. Okay, so Now let's jump into Avogadro's law. So what is Avogadro's law? So it is a fundamental principle in chemistry that describes the relationship between the volume of a gas and the number of particles present in it. Okay, assuming constant temperature and pressure. So the law states that the volume of the gas is directly proportional to the number of particles or the amount of substance of the gas, that is known as N lah. In mathematical terms, Avogadro's law can be expressed in this equation, which is V equals to Kn. Okay, so where K is a constant proportionality that depends on the temperature and pressure of gas. Okay, so basically this is Avogadro's law is represented by this equation lah. Okay, V equals to Kn. So K is a constant proportionality. Okay, on the temperature and pressure of gas. Okay, this is volume. As we know, V is volume. N is the gas lah. Okay, N is known as gas lah. Okay. Okay. So next one, the ideal gas law is the equation of the state of an ideal gas that relates pressure, volume, quantity of gas, and absolute temperature. Okay, so this is the ideal gas law equation lah. Okay, so in this equation we can see is P times V equals to nRT. Okay, P equals to pressure, V is volume, N is represented by the number of moles of gas, R is the ideal gas constant, and T is the absolute temperature. Okay, although it applies to ideal gases, it approximates the behavior of many real gases. Okay, so this is the ideal gas law formula lah. Okay, so the things that you must know also, okay, is the conversions lah. Okay, so these are the conversions that is important lah for this topic here. So you might be encountering all of this lah. So let me explain to you all of these conversion meanings lah. Okay, so based on this slide, as you can see, conversions. Okay, 1 millimeter equals to 1 torr. Okay, and 1 atm atmospheric pressure equals to 760 millimeters. Okay, and 1 atmospheric equals to 101,325 Pascal, and 1 atmosphere equals to 101.325 kilopascal. Okay, so these are the conversions that you must take note lah. Okay, take note. Okay. Okay, so this is there are 4 questions here. Okay, these are 4 questions here given in this slide. So please attempt these questions lah. Okay, so try to do it. It is based on this. It is based on this ideal gas law formula lah. So try to attempt this question lah. Okay. So remember, try to attempt lah using this formula lah. It is related lah. Okay. Okay. So next, deviations from ideal behavior. Okay, deviations from ideal behavior. So let me explain. While the ideal gas law is useful approximation, in many situations, real gases can deviate from ideal behavior under certain conditions. Some of the factors that can cause deviations from ideal behavior are high pressure, low temperature, real gas molecules, non-ideal behavior, and high molecular weights. So these are the deviations from ideal behavior lah. Okay, all of this. Okay, high pressure. High pressures, the volume of gas molecules becomes significant compared to the total volume of the gas, and the intermolecular forces between the molecules start to affect the behavior of the gas. This can cause deviations from ideal behavior. So this is the explanation of high pressure lah. Okay, for low temperature, okay, at low temperature, the kinetic energy of the gas molecules decreases. Okay, and the intermolecular forces between the molecules become more important, leading to deviations from ideal behavior. Okay, so that is for low temperature. Okay, for real gas molecules, real gas molecules have finite size and interact with each other through intermolecular forces. In real gases, the molecules have a finite size and they interact with each other through attractive or repulsive intermolecular forces. These interactions can cause deviations from ideal behavior. Okay. Next, non-ideal behavior. Okay, so Non-ideal behavior in gases that have polar molecules lah. Okay, it's more pronounced in gases that have polar molecules. Okay, in gases that have polar molecules, the dipole to dipole interactions between the molecules can cause deviations from ideal behavior. Okay, for high molecular weight. Now it's high molecular weight. So at high molecular weights, the size of the molecules becomes more significant compared to the total volume of the gas. And the intermolecular forces between the molecules become more important, leading to deviations from ideal behavior. Okay, so this is also a question also lah related to uh, perfect gas law lah. So try to attempt this question lah. Okay, try to attempt. If you have any questions, you can ask me. Okay, okay. So think we are done already lah for chapter 4. Okay, so that's the end for our lesson lah, of our lesson for chapter 4. So we have completed chapter 4. It's a short lesson just talking about gas lah and their relationship. Okay, so everyone, I think that's all for our lesson for today. Okay, so if you have any questions, feel free to ask me. Okay, feel free to ask me. So I think we'll end the class here. So that's all for today. Thank you for your time, and I'll see you in the next lesson. We will continue with our last chapter, which is chapter 5 lah. Okay, alright. So thank you for your time. I'll see you in the next lesson.